Thermal imaging of geohazards is not something that's new. What is a little bit new about what we're doing is thermal videography. We should be able to see rockfalls at day and at night. Hi there, my name is Chad Williams, and I'm the Assistant Director of the Geotechnical Center of Excellence at the University of Arizona.
My name is Edward Wellman. I'm a geological engineer. Today we're running a rockfall test with the thermal imaging system for rockfall detection. It's a system that we have 4 cameras on board. 3 of the cameras we're testing today. And we're going to roll rocks down a 900-foot high slope, and we're going to observe what we see from the thermal cameras and if we're able to detect the rock falls and what they look like on thermal imagery. This project is important for the safety of miners. One of the top 5 risk miners face in their work environment is the risk of rockfall and identifying other hazards. And so if we're able to use these cameras to, one, observe and detect rockfall, that may give us the potential to early alert.
There are few tools actually that track fast-moving objects. So we have a lot of tools like the one that's behind me just around the corner, a ground-based synthetic aperture radar or ground-based real aperture radar that are really good at tracking slow displacements. However, when you have rockfalls and fast displacements, you have what's called phase ambiguities, and those radars aren't designed to track that kind of movement. But thermal cameras can see quite a far distance, and they have some advantages to those other technologies. One of those advantages is that as a rock rolls down a slope and disturbs that surface, the newly exposed surface is now a different temperature than what it was before. And so what we can see and what we hopefully saw in our tests that we ran today is that as rocks roll down slopes, we can see the trails and the paths of the rock falls and be able to detect and track those hazards. We're really trying to figure out what types of thermal cameras are best to identify, track, and detect rockfall. So we have a scientific grade camera. It's an A400 FLIR camera. This is a FLIR 632, a wide angle view, high resolution camera. And this is a lower resolution axis camera that has a fixed focal length. And part of this project is not just trying the best cameras that are available, we're really trying to find the price point or the economy of where we can detect rock falls, but we can also provide safety critical tools at a reasonable price. Because if we can find that some of these cameras, which only cost $5 to $7 grand, can detect these things, they could become quickly popular in mining.
This is solar-powered research in mining.
So the way we're powering it actually is with 6 solar panels. We have 3 on the top and 3 out on the ground behind the trailer. That's providing power to around 4,000 pounds of batteries, and it's a 24-volt battery system.
We're connected through the mine Wi-Fi over a wireless network here locally, but we also have a cellular data collection where we have cell phone reception and can transmit data to the engineers that need to review it.
Yeah, so what challenges do we foresee with the technology? Well, we've already found so far that these thermal cameras can see dust really well, so in extremely dusty conditions, that could be a challenge. It also could be an advantage for us because most rock falls as they go down slopes in mining generate a lot of dust. So if we can detect dust on a slope, that could be an indication of even a smaller rock fall that is happening. This project is going to test conditions in snow and rain, and a lot of those things are yet to be figured out. We're really just getting started here.